Alright, this is going to be a continuation. This is a continuation, as I just previously stated, of our discussion of finding composite functions. Now, remember that we found the tangent theta is equal to 5/12, remembering that this is your y, and this is your x, or your opposite and your adjacent. This is your theta. And remembering that since theta is equal to the inverse tangent of 5/12, I can rewrite the cosine of the inverse tangent of 5/12 simply as the cosine of theta. But remembering that the cosine of theta is going to be this theta, and the cosine of theta is going to be equal to adjacent over hypotenuse, and in this case that's going to be equal to, and like I said, this one right here was going to be 5, this is 12, and this hypotenuse is 13, so we can write this as 12 over 13, and therefore we know that the cosine of the inverse tangent of 5/12 is equal to 12 over 13. So let's do another one so that we can make sure we fully understand what's going on. So we're going to start off with, let's find the exact value of the sine of the inverse tangent of 3/4. Well, once again, I know that the tangent inverse, or inverse tangent of 3/4 is going to be equal to theta. In fact, I'd rather write it this way and say that theta is equal to the inverse tangent of 3/4, and therefore I need to find the sine of theta. Once again, I'm going to use the Pythagorean identities and the Pythagorean Theorem to help me find this. So we go ahead and draw our xy coordinate system, and we need to determine what quadrant this is in. So we know that the inverse tangent here is positive, and that means that tangent is positive in quadrant 1 and quadrant 3. However, the inverse tangent will be looking at a quadrant 1 angle. So we can draw our angle with its terminal side. Here's our theta, and then we'll go ahead and draw an opposite and an adjacent side, the hypotenuse, the opposite, the adjacent. Since tangent theta from this is equal to 3/4, we know that this is the opposite over adjacent side, and I can use that to help me find the hypotenuse, noting that since opposite is 3, adjacent is 4, it follows that the hypotenuse will be 5, since this is a 3, 4, 5 right triangle. And since we're looking at the sine of theta here, we know that the sine of theta is going to be equal to the opposite over the hypotenuse, so that will be equal to 3/5. And therefore I know that the sine of the inverse tangent of 3/4, or 3/4, is equal to 3/5. Okay? Now, let's go ahead and do one that's a little more complex. And let's consider the following. the cotangent of the inverse sine of negative 1/3. So once again, this right here becomes theta, and I'm trying to find the cotangent of theta. And since theta is equal to the inverse sine of negative 1/3, it follows that the sine of theta is equal to a negative 1/3. Now, since sine is negative in the third and fourth quadrant, we have to decide which quadrant we're in. But remember that the inverse sine is going to be restricted from negative pi over 2 to pi over 2. Which means that we will be quadrant 4. Okay, so how do we figure this out? Well, let's go ahead and draw our coordinate system. And since it's in the fourth quadrant, we'll draw an angle. We will assume that this angle will be negative, since it must be between negative pi over 2 and pi over 2. I also note that since we're dealing with sine, this and this is going to be my opposite over my hypotenuse. So the hypotenuse, h, is equal to 3, and my opposite in this case will be technically a negative 1, and that means that I need to find my adjacent. And we know that x squared plus y squared is equal to r squared, or adjacent squared plus opposite squared is equal to the hypotenuse squared, or little a squared plus little b squared is equal to c squared. Any one of those three will work. I'm going to go ahead and use this one, and I know that a will be equal to the square root of h squared minus o squared, which is going to be equal to the square root of negative 1, oops, sorry, that'll be 3 squared minus a negative 1 squared. So a is going to be equal to the square root of 9 minus 1, which is the square root of 8, which is equal to 2 times the square root of 2. Okay? So let's go ahead and complete the problem, because we are looking for the cotangent of the inverse sine of negative 1 over 3. And the cotangent of theta in this particular case is going to be equal to the adjacent over the opposite. And since the adjacent is 2 square root of 2, and the opposite is negative 1, this will be equal to negative 2 square root of 2. Alright, let's find one more. Consider or find the exact value of the cosine of the inverse sine of negative 1/2. So we're going to do the same thing. We're going to try to figure out what we're looking at. So I know that this right here is going to be theta. Theta is equal to the inverse sine of -1/2, which means that the sine of theta is equal to -1/2. Once again, we have to decide what quadrant it is, and we know that it's going to be quadrant 4 because of the restrictions on the domain. Therefore, I want to find the cosine of theta based upon the information that we're given. So I can go ahead and draw my triangle. I know that it will have this orientation because it'll be in the 4th quadrant. This is going to be my theta. Now, what do I know? Since it's in the 4th quadrant, sine is negative. Therefore, from this, we will find out that the opposite is -1, and the hypotenuse is a +2. Okay. In addition, though, we already know that the sine of theta equals -1/2 yields the fact that theta is equal to a certain value. But we'll go ahead and we'll use the Pythagorean Theorem. A squared plus b squared is equal to c squared, or adjacent squared plus opposite squared is equal to hypotenuse squared, whichever way. So therefore, I need to know what the adjacent side is. Which means that a squared is going to be equal to 4 minus 1, which is 3. And therefore, a is equal to the square root of 3. Remembering that the cosine function is adjacent over hypotenuse, we know that this will be the square root of 3 over 2. Since opposite was equal to -1, hypotenuse was equal to 2, and obviously the adjacent side ends up being the square root of 3. So therefore, we know for sure that the cosine of theta, the cosine of the sine inverse, or the inverse sine of -1/2, is equal to the square root of 3 over 2. Alright, so let's do a simple application problem. And this one says the formula theta equals 2 times the inverse tangent of 21.634 over x, and I'm going to go ahead and put parentheses around that, gives a viewing angle theta in radians for a camera whose lens is x millimeters wide. Use this formula to solve exercises 95 through 96. In 95, we want to find the viewing angle in radians and in degrees to the nearest tenth of a degree of a 28 milliliter lens, which means that x will be equal to 28, and therefore theta will be equal to 2 times the inverse tangent of 21.634 over 28. And you will need your calculator to perform this calculation. So once we punch this into the calculator, we get 1.32 radians, which means that theta is going to be equal to 75.63 degrees. And that would be your viewing angle.